So welcome to the famous Dvors River Heritage Site. I spent here many times with my students showing this beautiful place. You are supposed to say, wow, how it's possible, what a fantastic place, etc., etc. About 2 billion years ago, these zebra stripe rocks were part of the enormous underground pool of molten rocks of magma. And then from there magma was rising upwards toward the Earth's surface, but they didn't reach the surface, but they were treated as a seal, like horizontal body. They stopped below, maybe 3-5 kilometers below the Earth's surface, and magma stopped there and cooled and started crystallizing, forming the layers, horizontal layers. So you bring new magma, it's depositing layer, another one comes, and you're depositing another layer, then another one comes from the deep storage to the shallow level, and this way we formed such kind of stratified magma chambers, which we called layered intrusions. Luckily for us, the erosion works hand in hand with us, and then erosion of this part, so that in some parts which are mostly eroded, these parts of the bushveld, they come to the surface. That's the eastern part, and that is the western part, and these are parts which we basically can study and can examine, and this is where all mining takes place. The reason why we're here, not because of these anorthosites, but because of rocks which are a little bit sitting below these anorthosites, these black ones, which are called chromatites. These are rocks which are composed of one single mineral called chromite. It's very valuable mineral because basically that is the only mineral from which we extract chromium, which is very important industrial element. We use it mostly in steel industry because chromium together with vanadium makes steel stronger. It also makes them corrosion resistant. So that's what really makes chromium important for our human society. The Bushveld igneous complex is the largest layered intrusions in the world and the largest fossilized magma chamber in the world. Just to give you an idea about the size, so it's 9 kilometers thick, more than 400 kilometers in size, and it occupies an area comparable to the size of Iceland, for example. We know for a long time that the magma which we need to produce such kind of layers, it should crystallize chromite as single mineral. And it was clear for us for a long time, but the problem was always where to get such magma. All these basaltic magmas, they are coming from the mantle. The mantle is rich in mineral which is called olivine, and of course if you melt the rocks which are rich in olivine, when this magma comes to the shallow level and crystallize, it will crystallize olivine, not chromite. So that's why we have been trying hard for many years, for decades, to produce this ore-forming magma in the shallow chambers. And that's what I started thinking, so why, if we cannot get these magmas in the mantle, and it seemed that we had a problem to produce this magma inside the chamber, in the shallow chamber like Bushveld. So maybe then the answer is that these magmas may be converted, these magmas, normal basaltic magmas which are produced in the mantle, maybe there's a trick is that they are converted into the one which produce deposits on the way from the mantle to the shallow level. So that was the idea. We realized that some magmas, when they're taken from the high pressure, from the depth to the shallow level, they are converted into the one which can crystallize chromite alone. So this research is just a start of our new novel line of research, because we feel that we got an answer not only for the chromatites, but probably for other magmatic deposits as well. And we suspect that there are other magmatic deposits, like vanadium-rich magnetite layers in the Bushveld complex, which may also be ultimately related to the same process.